everyone. Welcome to episode number 682 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by me, Amelia Dalton. Folks, this week we're talking about the future of embedded software development, especially when it comes to safety and security. For years, verification and validation, or V&V, has relied heavily on manual, time-consuming processes. But now, that's all changing. We're seeing a major shift as modern AI technology is integrated into the essential tool chains that build the safe systems we rely on, from automotive to aerospace and robotics. My guest is Tasking Co-CEO Christoph Herzog. Christoph and I explore how large language models and agentic AI are moving from novelty to necessity, directing external agents within the tasking toolchain to automate critical verification and validation tasks. We also discuss the Model Context Protocol and how it helps maintain adherence to strict industry standards. So, without further ado, please welcome Christoph to Fish Fry. Hi, Christoph. Thank you so much for joining me.
Hi, Amelia. Thanks for having me. So it's great talking with you.
Excellent. Thank you for joining me. Okay, so first off, give me a brief introduction to tasking. Tell my audience a bit about tasking and what you guys do.
So in one sentence, and I go deeper after that, but the beginning is always so tasking, we are like translating human readable code to machine readable code and that in a safe way. So that is what we do with our compilers. The second thing we do is we take your hardware and you have an issue, we fix it. And you would like to how good your code is, we test it for you. So that's why we always stand for compile, debug, test. That's, let's say, in a nutshell. We are standing for best-in-class software development tools in the embedded space when it goes to mission-critical and safety-critical systems.
All right, so Christoph, before we talk about the integration of AI into the tasking tool flow, talk to me about the challenges specifically of software verification and validation and how AI can help these workflows and processes.
Yeah, the interesting part is always when you talk to people, they think the most challenging part is the code creation, or you spend most of the time in writing code and doing stuff like that. But the reality is that verification and validation is actually the most time consuming and last scalable part of embedded software development. So you often have to run step by step to check if something is working or not. So you're dealing with high complex code bases you need to test. You have MCDC, so multiple conditions you need to test, and all of that with a strict safety and security standards in mind, like we talk about ISO 26262 in automotive for safety, or DO 178 in aerospace and defense. So this is really the complexity we need to handle. And this is the topic also you need to have a human review capacity in to check if it's working or not, if the tests are really working on that, not. And the challenge often is you need to test against something. So the real challenge is the lack of data. So the lack of data which are validated and really working, because you have so many data. You actually have data for everything, but you really need to think about which data are validated and that you can use them. And where AI is really interested, like what I mentioned at the beginning, everybody is like, oh, AI is my code writer, but it's more like for us, where we see it's really interesting is consolidate the results across different tools, check if they are really working, see if there are patterns and anomalies which humans might not see. So really we think AI is really strong at pattern management or pattern recognition, and it also helps a lot of the engineers to navigate through this evidence finding and checking where is something to look at. So this is where we see that AI really adds value to the testers, to the people who are really testing and validating, to reducing this brain power to really find the spots that are hot where they should look at.
So, Christoph, how does the integration of agentic AI workflows, particularly utilizing the open source model context protocol, specifically help developers maintain adherence to these strict industry standards?
The topic is I shortly mentioned some standards. Standards like ISO 26262, IEC 61508, or DO 178 were also MISRA C. They don't just require, let's say, correct software. They require evidence. You need to show evidence. And evidence in software means it's traceable, it's auditable, it's reviewable, and you have everything in evidence check. And agentic AI helps us to structure AI interactions that, first of all, every output is logged. So you have a logging. Then everything you do has a context awareness. And every output is not only logged, but it's also traceable through a verified source and a verified tool. And that what makes it audible. When you take certified tools with agentic AI, it simply gives you these inputs. And that's why from tasking, we have MCP servers, so model context protocols for our compiler, for our debuggers, for our LUA tool suite, which is used in the validation and the testing. And here we then see really the real connection to bringing this together. Real certified tools with AI, agentic AI, is really a game changer for us.
So, Christoph, can you give me some examples of how an LLM would direct external AI agents within the tasking toolchain to automate tasks like optimizing compilation configurations or managing iterative compile, debug, and test processes?
Yeah, shortly also to what I mentioned before, MCPs. So the topic is like with this, you define also clear boundaries between the LLM's reasoning, what is the input from the tools, and also that the verified data sources are using. This means with this MCPs connections to our certified tools, the AI is no longer, we also call it guessing or hallucinating. It's really coming to real certified outputs. And examples where LLMs are then like for us, not the executor, but the orchestrator between these tools is, for example, in compiler optimizations. So the LLM, what they can do, they can review performance and size benchmarkings for us. They identify trade-offs and regressions. They can tell you which compiler option is working good or not good, and giving you alternatives, compiler flags, and even benchmarking this. So this is something, for example, for compiler, where we also work together with AWS, and we can then show this to our customers, where we brought together AWS Cairo and our compiler and run multiple benchmarks. And we could simply say, can you tell me for my specific function of the combination of 500 compiler optimizations, what are the best when it comes to size or speed to specific benchmarks? And this was a really weekly long process, which was downstreamed in an evening or a night. So that's really helping there. On the other hand, so that was, let's say, compiler specific. You also ask about, let's say, the cycles when it comes to compile, debug, and test loops. So what we see and what we're already working on is like monitoring the build results and the test outcome, detect the failure patterns because LLMs are good in pattern recognition, trigger a deep analysis or rebuilds because also LLMs can rebuild from build failures, and then present the engineer really with insights, not only the log file, but really more insights that he can better judge. Important, what we always say also, independent if it's the compiler use case or this compile, debug, test, and verify use case, at the end, the human engineer remains in control. The LLM, or in general, the AI, is accelerating the progress and making everything faster, but it can make the correct decision. What is the best compiler option for my case? He can make you proposals, but he shouldn't make the decision. We think this is important and human stays in the loop there.
That makes sense. So, your recent announcement mentions that the tasking toolchain provides a rich array of reports that can be ingested by LLMs. So, what types of data do these reports contain, and how does this data ensure that the LLM or AI agents have accurate data for making these critical decisions?
Mhm. Yeah. So what we provide today is, or in general, all our tool chains. We really generate a complete set of structured and machine readable reports, like compiler diagnostic, optimization reports for our compiler, the benchmarks I mentioned, like code size and performance metrics from our debugger, the debug and trace data, or the execution timing or worst case execution timing data, static analysis results, and also build information. And why I can use this to ensure real accuracy is because all of this data, even if it's like orchestrated by an AI, it's coming from not a probabilistic, but from a deterministic tool, which is really generated from this qualified tool. And this is something together with an LLM you can build into your build and execution environment. And that which makes you as a team, as a developer, as an OEM, as in tier one, so much faster because you go away from, let's say this, we often say this chat GPT, like asking a question and getting feedback, doing the loop again, performance measurement. You're really getting into a running loop that is generating trustful artifacts for you, which you really have built in your AI agents.
Fantastic. All right. Before I let you go, Christoph, it's time for your off the cuff question. So, if you could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there, what would you have?
Okay, so maybe one do it. So I'm a big food fan in general. So, and I also think that food and engineering has a lot in common. So you patience, you need craftsmanship, and that is why I would choose sushi. So a really good done sushi with fresh fish, that's my choice.
What a good choice. Well, Christoph, this was fantastic. Thank you so much for joining me.
Thank you much for having me, Amelia.
If you would like even more information about this topic, I've included a couple links below the player on this week's fish frying page on eejournal.com and in the description for this week's YouTube episode as well. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If LinkedIn is your thing, I dig it. You can follow us or me on LinkedIn. And we are also on Blue Sky Social and Mastodon as well. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me. And of course, you can subscribe to our EE Journal YouTube channel as well. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's Amelia at eejournal.com, or post a comment on our forums on EE Journal. For the week of May 15th, 2026, I'm Amelia Dalton, and you've been fried.